Hello everyone, wishing you a very happy new year. In the process of learning general relativity, you might have come across many books, research papers, write-up and other valuable resources. However, today I am going to talk about such a hidden gem, a book that will not only change your perspective of learning general relativity, but will also make you happy. A book which will transcend you to the time where you will witness how concepts such as time dilation, metric tensor, equivalence principle, free fall, geodesics, Riemannian geometry were formulated. You are going to see the moment of creation. This book is a chronological development of Einstein's ideas of space-time, gravity, his journey from the early struggles with Newtonian mechanics to the revolutionary formulation of general relativity. My name is Shaunak and you are watching this video on my channel Physics for Students. Let us learn how Einstein developed general relativity. Now, if I start with the number of available books on general relativity, you will be confused. Also, you will feel pretty happy because there are so many options that are available. You go to any bookstore, you go browse Amazon, you go to internet and Google, and you can find out there are so many books which are available. Some of them you might have read, and some of them I have already done certain reviews in details on my channel Physics for Students. Now, out of all these books, as you can see, there is something of Suskind's book, Robert M. Wall's book. I would like to say certain things which are important. Now, based on the availability of the books can be generally divided into certain categories. And these are important because once we understand the categories, then we understand the purpose of selecting the book and then the process of learning. So the first type of books are called very introductory books. These are basically aimed for, I would say, enthusiasts which have got no such a strong background of mathematics and physics but willing to learn general relativity. You will find a lot of people who are willing to learn that. The second type are called textbooks, and these books are basically targeted for graduate or undergraduate who are studying GR for a physics curriculum or for a very formal understanding of GR. The third book is called the advanced textbooks, and these books are more mathematical in nature and they go deep into understanding certain concepts like tensors, differential geometry, and builds up the foundation of GR. The fourth type of books are called the mathematical treatments. That means much more than the physics and the developments. The mathematics is dealt in much more details. And then comes the fifth type of book, which are called popular science books, which I consider to be very dangerous. These books basically introduces GR to a very general audience, not considering the mathematical details, and you really don't need any mathematics to know that background. Just an overall idea of general theory of relativity. Now, these are the broad 5 categories. However, you can subdivide further into it. So the question then comes that which is the book that I'm going to select, or which book will you select? The answer tells that it depends on your objective. That means depending on the level of understanding, depending on the target that you set for yourself, the selection of the books really happen. So in case, for example, you want to gain a basic conceptual understanding, not go into the basic details of that, a minimal mathematics, I would suggest this book would be very important by Thomas More, Realist Guide of Space-Time. You can also look into the famous James B. Hartley's Gravity, and also this book I have got in my collection, both the last 2 books, Gravity as well as Kip Thorne's Black Holes and Time Warps. It's a very heavy, around of a 700 pages book, but it gives you a very good understanding without knowing much of mathematics. If you're going for preparing for exams or university course, you should go for Sean M. Carroll's book, Space-Time and Geometry, or you can go into Introducing Einstein's Relativity by Dean Verno and Vickers. However, Sean M. Carroll's book is something really wonderful, and I think that everyone should start with that. I have done a little bit of review also in my earlier videos. Now, if your target changes, as I told you, the objective changes to developing advanced and expertise in general relativity, then I should say that Wisner, Thorne's and Wheeler's book, Gravitation, which is again a very heavy monster, you can go through it, or you can also go through Robert M. Wall's General Relativity. These are for developing advanced expertise in general relativity. And if you want to learn the foundation, that is basically you just want to learn the pure mathematical part before going into the physics part, then this book is very good. I think this is by Birkhauser, Physical and Mathematical Foundations of the Relativity and a Mathematical Journey to Relativity. So these are the different categories depending upon your target, your audience, your objective. These are just sample few of the books, but there are many books on that. But as I tell that one thing is missing in this book, which would bring us to today's topic. Now, what is missing in these books is none of these books contain account on the evolution of relativity. Now, I'm not talking of history. I'm talking of evolution. That means in order to understand what we learn of the general relativity terms and references and the mathematics, there is a kind of a scientific process, and this has been defined in the evolution of relativity. So it shows the theories, how they are refined, and also you can learn from intellectual debates, including Lorentz, Poincaré, Minkowski, and how they foster the appreciation of a collaborative effort which leads to today's relativity. So these books do not contain this. Also, this book doesn't contain how Einstein developed relativity. So what was the inspiration? What was the thought experiment? How Einstein achieved that? What were the problems that he was facing in terms of geometry, tensor calculus, etc.? These are also not being covered in this type of books. The third thing which is also missing is called the beauty of manuscripts. Now, what do I mean by that? That if you really go through the manuscripts of handwritten, although we cannot read that, but at least through see those, feel those, and understand the translation, that it actually offers a unique connection, that what were the frustration, what were the elated moments that the creator, that was Einstein or Newton, whoever had. So the beauty of manuscript is a very important part, which I'm going to show you in today's video. So the scientific breakthroughs, the frustrations, the happiness, all those things comes much more evident, and the learning becomes much more solid when you learn the beauty of manuscript. So how the concepts of metric tensors evolved, these things are important to learn. When Einstein first encountered what is called geodesics, the concept of invariance, and Einstein's agony and ecstasy, telling that it is too complicated, and calling his friend Marcel Grossman to solve on the problems of tensor calculus, all these things become extremely important for our understanding. And these are the things which are missing in this book, and we are going to look into one particular book which actually shows you those things. So from here, what we can understand that yes, these things are important, not going into the history, but at least the evolution, and we can really appreciate the revolutionary impact of relativity and how this metric tensor, how these geodesics actually came into being. We are just getting a ready-made product, that is the concepts and the mathematical formulations. But the question is that how does it read to? And this leads to our next topic, which I call it as the road to relativity. And this actually brings us to the famous and the wonderful book that we are going to look into today, that is called The Road to Relativity. And it is written by Hanoch Gottfried and Jürgen Renn. These are the two authors. Here is a brief customer review. So more or less 77% people have told 5-star, but I won't be, exaggerating. I would have expected around 90% plus should be talking more about 5 stars. However, the stars really doesn't matter until you read the book and get a true understanding. So these are some of the screenshots from Amazon I have taken, which shows you the elegance and how people have appreciated. So how relativity came, great book, interesting on informative accounts, and certain other things. So these are all Amazon reviews, which gives you an understanding of how the book has been appreciated. Now, as I always tell that before selecting or going ahead to purchase a book, what is most important is that to understand about the authors. Because some of the authors assume certain things, some of the authors start teaching you right from the scratch, and it gives the credential and the credibility of understanding who has written the book also. So there are two authors, as we have seen. The first person is Professor Hanoch Gottfried. Now, Professor Hanoch is basically a PhD in theoretical physics from the University of Jerusalem. He is also in theoretical physics and has been a professor. He is also the director of the Einstein Center and is Hebrew University's appointee responsible for storing and talking more about Albert Einstein's intellectual property. As you can see that more or less Professor Goodfreund is mostly working on the history and philosophy of physics, particularly working on the manuscripts of understanding Einstein's relativity and putting that to a broader audience. So first thing we understand that we are at the good hands. Is a nice Professor Hannock, very senior person and taking care of the Einstein archives. So we are hopeful that we get the right data from the right person. The second person is Professor Jürgen Renn, and Professor Renn was born in Munich, and he's a German historian. So he studied physics at the Free University of Berlin and then the Sapienza University of Rome. I think Professor Ale Mastrodi was also from Sapienza University last year. We had a nice podcast. He has collaborated with extensively with physicists and historians. So he also is working on Einstein's manuscripts, arriving at the theories of special and general relativity, and spreading the light of wisdom to the broader audience. So what we can understand from here that both the authors are great people, and one of them is Hebrew from Israel, another person is from German. So because Einstein's carry a descendants of Jewish origin, and because his writings are in German language, so we get the right account. And Professor Hannock from Jerusalem will tell us more about the psyche and development of Einstein, whereas Professor Jürgen would be working more on the writing part, so we get the right data. So this is the reason I talked about the authors, so that we understand that we are on the right hands. We come to the next part, which is called how the book is arranged. Now, the arrangement of the book is necessary so that we get a kind of a mental understanding that this is how we are going to read the book. So the first thing that we understand is the charm of manuscript. This is the first chapter, and I have already given you an account why this is important, because the value of original manuscripts, Einstein an early manuscript, his manuscripts of writing in 1912, then 1916, and the significance of the manuscript, how it got transferred to Jerusalem archives, etc. So the charm of the manuscript, this chapter primarily talks about the value of manuscript, reading the manuscript, understanding the manuscript, and from that manuscript getting an idea of the mathematical and the psychological and philosophical development. The second chapter of the book talks about Einstein's intellectual odyssey to general relativity. That means this is primarily the area or the chapter where we would be learning about the entire development of Einstein's relativity. So the challenge of gravitation, the equivalence principle, the geometry, how it enters, the Antwerp document, and finally it will culminate to the 1916 manuscript. So this is the part where the authors, I would say, are talking mostly about the development of Einstein's general relativity. All the concepts of physics are actually talked in this particular chapter. Then we come to the most important chapter, which is called the annotated manuscript, and the entire core mathematical part, starting from what we call special relativity, general laws of the nature, the geodesics, Riemannian curvature tensor, non-Euclidean geometry, differential geometry, everything is being discussed over here, the annotated manuscript. We will see how it reveals in front of us. So first we understand the importance of manuscript, then we see a kind of a historical development of Einstein's theory of relativity, then we go to the core mathematics. Other than that, the book is also divided onto the certain notes. There are certain notes 1 to 3 where the annotations of the pages, a chronology in the genesis of general relativity. Also, we will see who were the physicists, who were the mathematicians who were prevalent, who were also thinking in the same term as Einstein. And there is an English translation of the foundation of general relativity and English translations of Hamilton's principle of the general relativity. So this is all how the books and how the things have been arranged. Now what we come is what we call the development of ideas, and in this part, before we go to the book, I would like to tell that the development of ideas of this particular book is being done in this way. Now the man in this picture, which you can see, is an expert on Einstein, and he described as a trilogy of dramatic stages. So he is the Professor Emeritus John Stackel, who has studied at the Central University at Boston University. And in 1977, Stackel became the first editor of the Einstein papers. And the development of general relativity he has divided into trilogies. So first you can see 1907, the stage was set with Einstein's introduction of the foundational concept he termed as equivalence principle. The second act unfolded in 1912 as Einstein's insight revealed that the gravitational field could be expressed through 10 space-time coordinate dependent functions comprising of the metric tensor, etc. And in 1915, the triumphant conclusion arrives as Einstein crafted the gravitational field equations, elucidating phenomena such as anomalous precession of Mercury's perihelion and bringing his groundbreaking theory to fruition. So this is how the development of the ideas the authors have written. Now there is also an alternative script for his captivating narrative delving into his spatial concept. Now Einstein first conceptualized the equivalence principle during his tenure at the patent office in Bern, as you can see on the photograph, and Einstein also examined the immediate ramifications of his principle, that is the deflection of light rays within gravitational fields and the influence of gravity on the passage of time. The initial exploration serves as a prologue of the true unfolding drama commencing in 1911 when Einstein embarked on a journey in 1911 to Prague. So the authors they take it on as the Chronicle of Three Locales or something like that, which you will read in this book. So each city actually has become a stage of a particular chapter, as the authors write in this unfolding journey. Each location offered a unique social and political backdrop while also making a distinct phases in Einstein's family. The interplay between these circumstances and his scientific endeavors has been explored in various biographies detailing in his life and work in this particular book. So this was how the development has been framed, and we will start, the book starts with Prague, then to Zurich and to Berlin and so on. Now it is the time that we should move into the table of contents. So the table of content is very detailed, as you can see right on the screen, that the first it will start with the Einstein's intellectual odyssey we have just discovered, the annotated manuscript, and you can pause it and you can see that all these are annotated manuscript. Multiplication of tensors, sum aspects of the fundamental tensor g mu nu, then the equation of the geodetic line, then the formation of tensors by differentiation. On the right hand side you can see the general form. So entire mathematical development of the book is over here, the annotated manuscript. Next, if I show you, you will see that it continues and continues, and the appendix shows the field equation of gravitation matter and the chronology of Genesis, etc. Further reading are being suggested. Now this is the table of contents. Now we'll come to the content of the book. Now the content of the book is very interesting. The first part, which is actually called Einstein's Intellectual Odyssey to General Relativity, it basically gives you all these ideas. It starts with the tale of three cities, Prague, Zurich and Berlin. Then it will explore you and show you the challenge of gravitation, Einstein's heuristics, the equivalence principle, geometry, how it enters physics, that means the non-Euclidean geometry, the best that can be done, the rise of the N12 theory, and the final race of Albert Einstein and David Hilbert. So this section actually will give you the entire development, the evolution of general relativity as itself. Next we come to the part which is called the annotated manuscript, and I will just show you certain screenshot. Now obviously you cannot read the handwriting of Einstein and it is all written in German. So the first page will have the manuscript and then it will have the translation. Translation not in true sense, I have gone through both of the German and English writing, but overall the idea, how it was developed. Why did Einstein go beyond special relativity? Move to the next page, you will find another manuscript and again a kind of a translation on overall idea. What was wrong with the classical notions of space and time? Again. Then you go to the third and you will find this part. Why does Einstein's theory of gravity really requires non-Euclidean geometry? So wonderful, beautiful understanding of a step-by-step approach through the manuscript. You see the history on the left-hand side and read the modern text on the right-hand side. Also, I would say the book contains very good diagrams. I mean, it's a nice cartoons and diagrams which actually gives you a kind of an understanding of the book. And then you will see the content of the book, that is the physicists and mathematicians. There are many. I have just taken a few screenshots. Abraham Max Born, followed by Christoffel Elvin Bruno Christoffel, and most important person who taught him tensor calculus, Marcel Grossman. Now, if I talk of the review of the book, I will be very honest and I will tell you what it contains. First of all, I was just mesmerized. It's an excellent book that gives you a very chronological development with the struggles and the frustration that Einstein faced. You can actually witness, you can get transcended to that era of how Einstein is completing his general relativity. It is clear and simple, it is excellent, lucid, and you can actually find the mathematical concepts of tensors and etc. But you should also remember that it doesn't contain too much of mathematical exposition except the last translation of Einstein and Hamilton's part of relativity. Otherwise, it is a wonderful book. I think that if you once start the book with the first page, you are not going to put it down until you complete it. Here is an important note which I would like to add before I conclude for this video. The note is that when you will be going through the annotated manuscript, you will see all the mathematical concepts. It talks about special relativity, time dilation, then coming to equivalence principle. These are not explained in detail. So do not expect that there will be mathematical calculus, partial derivatives, differential geometry, etc., curves, etc., which will actually describe you. No, it is just the manuscript, the way Einstein is written, and the book is just putting it up together. Also, you will see, as I was telling, that these concepts are not explained with mathematical equations and proof systems, etc. So the book actually assumes that you have the basic knowledge and then you're reading it, so that it is taking you through the historical part, and you will see that how metric tensor was actually written capital G and then Einstein changed it to small g, and there are numerous excellent and I would say wonderful concepts which will come forward. So I would say this is an excellent book from my side. I would say it should be a 9.8 out of 10. Contains every single details, and it will give you a true note of understanding and development of general theory of relativity. So we will take a pause of today's video. So I would like to thank everybody for taking the time and watching this video. If you have liked this video, please do not forget to subscribe to my channel, Physics for Students, and also please click on the bell icon so that every time I update and you can get a proper notification from this channel. You can contact me at this email ID, and you can follow me in my LinkedIn, Twitter, and Instagram account. Thank you for watching this video, and I will be back. The new year have started, so a lot of good videos coming up. Stay tuned and see you in the next video. But till then, may the good Lord be with you.